said for the most part of this class, we answer questions for the homework. Okay. So let's begin with the questions. Okay. So which question you have?
It was on number 3, so there's like A, B, C, D, and E. Do you want us to find the boundaries, midpoints, and widths for each one of those groups?
Okay.
Or all of them together? Because I attempted all of them together, but it's really weird.
Question number 3?
Mm-hmm.
Okay.
We can't see the screen.
Actually, all I have not done yet. We are still talking about this. Okay.
I was trying to balance
So,
it, but it didn't
so
work
the
out
file
so
is
well.
open, I'll tell you. But now you should be able to see my Chrome, like Google Chrome. Let me see. Google. Yeah, it's not here. Okay, now you should be able to see this. Okay. Okay, we are going to talk about the question 3, right? Question 3. Can you read the question? That has a lot of small questions, right?
What was that?
Question 3 has a lot of sub-questions.
Yes.
Let's just do one of them.
Okay. Either
Okay, let's do this. Okay, let me make sure everybody can see this.
D
Okay?
or E. So
It's a Python program, which I like. Okay? It's an older version, but you see everything is a top. Whatever we need is there. Okay, question number 3, right?
Yes, but can you either do D or E because they have the decimal points in them?
Okay, let's do, which one you pick up? D, how many decimal places?
1, and then
Okay,
E
that's
has
good.
2.
Let's do D, D. Okay. Like this?
Yes.
Okay. Can you read the question?
Find the class boundaries, midpoints, and widths for each class. And then D is
What is given?
12.3 to 13.5.
12.3 to
13.5.
I think it's a good question. Okay. And according to your understanding, what are these two numbers? Are they boundaries or limits? Limits, good. Okay. So these are the limits. Limits are the values the data may actually reach. Is that right? So these can be data values. Okay? So they are not boundaries. Can you give another? Is that a second interval? Just one interval?
That's all that's for number D.
If you guess, what will be the next interval? Especially the lower boundary of next interval.
13.5 to 14.5?
13 point. What?
5?
No.
6.
6. I think you can figure out this. Okay. You can figure out this. But no. It's hard to figure out right now. Because I need to add the width, right? Width, however, is not calculated from the limits. Width is calculated from the boundaries. Now to a figure. This is 12. Always do this, okay? On the 3. This is 13. 45. Let's check here. I will let you come to yourself. Where? Okay, you see, right? Okay, go to yourself. To yourself, okay? Is that good? Okay. I said these are the limits, right? These are the limits. Okay. They are not boundaries. So let's see the boundary. Okay? The first boundary should be here, right? Is that right? On the left. How many decimal places that boundary should have? Well, we said already, limits are potential data values. In other words, data values have one decimal place. So boundaries should have one more decimal place. So it has two decimal places. So it should be 12 point something, right? The last digit is always 5. That's convenient selection, right? So what's the first?
2.
Oh, sorry, I think I made a mistake already. Yeah, it's correct. I have to look at this. Okay. The point is between 2 and 3. Okay, it's correct. Okay. So what is that number? It turned out to 2. If 12.25 is larger than this number, it will be on the right hand side.
Well, but it's 12.3, so 12.25 is lesser than 12.3.
Oh, yeah, you're right. You're right. Okay, sorry. I missed a look at this number. I always think it's something 0.23.
Yeah.
I saw that. Okay, it's not. The point is off the chip. Okay. You're right. Okay.
This is page 46, 3D.
Yeah.
Okay. Let's look at this again. Okay. In the original given form, these numbers are limits. Okay? Not boundaries. We need to recover the boundaries. Without the boundary, we are not able to compute. Even for the width, we use boundaries to calculate. Right? From lower boundary to upper boundary, that gives the width. Not from lower limit to upper limit. So boundaries is what we should start from at the beginning. So how to determine the boundary? Okay, we are here. This is the smallest data value. The first boundary is on the left-hand side, right? Also, it has one more decimal place. So for this data value, it has one decimal place. So for our boundaries, 2 decimal places. Now with that information, you should come out with this number. Okay? It's a number to the left. It has 2 decimal places. Right? Okay. That's how you determine the first lower boundary. How about the upper boundary?
13.55.
You add 0.05. Then you are able to calculate the width. I guess at that point the question is the answer, right? So the rest should be straightforward. Okay. So this is where we determine each other between the boundaries and the limits.
So for number E, it has 2 decimal places. So that means whenever you calculate the width, it would end up being 3. Is that right?
For E, let's look at D. For D, when you calculate width, as you see here, you see 5, right? You also see 5, right? When you do a subtraction, that 5 is gone.
Right.
So it has 1 decimal place.
Well, I know, but like for number E,
I
there's...
know you're talking about E. Let's look at this.
Okay.
Okay. Let's look at this first. Okay. When you do a subtraction, this 5 will be gone automatically. So at the end, you see just 1 decimal place, right? Which is the same as data value. So the width has a pattern like data values. For E, what are the numbers? What are
3.18 to 4.96.
I'm sorry?
3.18.
Like this? Let me change the color. I prefer this to be, if not perfect, at least almost. So this is, you said 3.18.
Yes.
That's unlimited, right?
Yes, and then 4.96.
I'm sorry?
4.96.
4.96.
96.
Well, this is useful. And those are the
limits.
limits. Okay, let's follow our discussion to see the boundaries. What do you think about the boundaries? So the boundaries will have 3 decimal places. So that will be 3.175. So how about this?
4.965.
Huh? Okay. 4.965. I think I can agree with that. It's correct. Okay, that's how we determine the boundaries. Remember, you always get a boundaries. Once you see the boundaries, I think you feel comfortable, right? Because with boundaries, when you calculate the width of the interval, you do a difference. You cannot use the limits to do a difference for the width. The width is not the limit. The width is between the boundaries.
So then for calculating like the midpoint, it would only be one number,
For
is
either
that
boundary, you
right?
can use either way. You can use the boundaries to calculate. You can use the limits to calculate because they have symmetry.
But it would only end up being one number since there's not
the one
multiple.
number. It's one number, but the results will be the same.
Right.
Okay, you can use either boundaries or the limits. Yeah, that's a good question. Although it's a short question, but it clarifies the concept, right? Remember, if you start with boundaries, you need to define what are the limits. If you start with the limits like here, you need to determine the boundaries, right? Okay. You cannot have both. You can only define one, and then you develop the other. Okay, that's good. That's a very good definition. Okay. I'll post this to the PowerPoint, so later you're going to see. We can still have more. Okay. Let's see another question. Do you have another question? Not an Excel question. Okay. For Excel question, we have other things prepared already.
So no Excel questions.
We'll do that later.
Okay.
Because now with this one, we can answer other questions, not an Excel questions. Okay. Do you have other questions other than Excel questions? No? Okay. If there are no questions, let's move to the Excel questions. So let me copy this to the.
Hmm? Because it's 3, 7, and 12 for this page, right? So it says on there. Because you had pulled that. I thought you did anyway. Yeah, like what questions for page 46?
I think I can put that somewhere in the. I think let's just put that before. For concepts. Let's put that here. May not be a correct place, but you can just display yourself. Later I'll post a file. Okay, now let's do an Excel question. We have 3 questions using Excel. 12, I think I mentioned that already. Number 13, and then number 7. For number 7, you do by yourself. Okay. I'll tell you what is the very first step. I told you already, but I'll tell you again. So let's try number 13. Okay? Number 13. First, when you perform parameter analysis, it involves 2 bigger steps. The first of the two big steps is to calculate the intervals, to find out the intervals. For that, you essentially do not use Excel. You do not use Excel. When you use, it's just like you use a calculator, you add numbers, divide numbers. So that means you do not use Excel. The second of those two steps is where you use Excel. Again, determine the intervals by hand. After that, use Excel to count the frequencies of each interval. How to construct the intervals? I have a file post. Actually, we discussed this in the class. Okay. Using that regular high temperature data. So you need to get familiar with this file.
Professor, I have a question. If we're doing some of these problems in Excel, how do you want us to see them?
Okay. For that, actually, the answer is much easier than you write on the paper. You can copy that Excel result back.
I just put it to the bar.
Yes. Okay.
But on the example that you showed us the other day, it was like in a, I don't know what the word is, but like a table, with the boundaries and limits and then the frequency.
Yes. That's it. You have to do that by hand.
Oh, right.
Excel is not going to perform that.
Right.
Excel cannot perform it. That's not here.
Okay.
I think this computer is different. I cannot switch it. Hey, what's this? Hey, that's rotating. Yeah, that's good. Is that good?
One more. Two more
Why
times.
you have to do that way? Yeah, you know what? I'm trying to tell you something. I said, and maybe in this group or another group, they are giving us two instruments so that I can write here. Then everybody should say the other way. Okay. Because when I write here, the camera is here, right? It's upside down. So I cannot change. I cannot be like this. I cannot do. So if I write like this, what you see is just like that. So you need to solve that problem. So how you solve that problem? You see it upside down. Then it's right. So I think I told them I'm not going to use this. Okay. That's too difficult for my students. So I want to give them back. Okay. And it's real. They take that very serious. They found that. Is that in this class or another group? But in this room.
That was Tuesday.
Okay. It's another group, right? Okay.
Because I heard it on
Yeah, so we got that. We got that. It's a good thing. Okay. But the camera is here. Okay. And the connection is this. I actually in the room is not a problem. Inside the room is not a problem. Inside the room, as long as I can see here, whatever my view is, you see this. But the question is, how to connect that to the Wi-Fi so that those outside the room can also see. So you need to connect two computers. That's too complicated. I said stop. Not like that. So I prefer this. Okay? I recommend this. Also, this is bigger. Okay? This is bigger. It's easier to read. Oh, for that, of course, there's a pen. The good thing is there's a pen.
Yeah, because that's a lot easier to read.
Yeah, that's easier for, but it's not easier for you because you need to sit that way. For me, it's easier. I can write here. Then, inside the classroom, students must sit outside down, level. And also for the outside students, they need to do the same thing. So it does not match the correct way, it's like that. Then the be a way to resolve that, but I think that's too difficult. Okay, this is what you need to think. Okay. Like number 12, number 13, number 7. You must go through this process. That's one step, right? For this step, you do not need Excel. However, you actually use Excel as a calculator, right? For example, for the max of a data set, you use Excel to calculate, right? For the minimum, you use Excel to find. And then for the range, you use Excel to calculate. The number of intervals is given. And then you do division, you can use Excel to do the division. Okay. Also remember, you always round the number up to obtain the width, right? Okay, later I will demonstrate this. Once you have that, then this comes to where we started with. Number 3, question 3, to determine the boundaries, right? Once you have one boundary determined, then every boundary, every other boundary is determined by eigenwidth. So for the left-hand side, there is no way to simplify this. And this essentially is done by hand. Okay? Do you follow this? The left side is a straight process which we are not able to change. Once the intervals are determined, then we use Excel to calculate the frequency of each interval. For that, you already have the intervals, right? You have the data. The boundaries of the intervals will be the bins for Excel. With data and the bins, you can use a histogram to figure out the frequency of each interval. That's the second step. Second biggest step. Now let's do this using question 13. Okay. Actually, in my post, you see it's a lot of details. It tells you how you do the data. Okay, that's where data is. How you do the bins, that's where bins, right? Okay. That file actually is also post. Okay. If you open this, file, it tells you how to do this. You can see step by step. You see? Well, I guess you know what the problem is. You have to. Well, each computer is different. This computer does not display everything. It displays just that part. Stop. I cannot see the rest. I cannot see the rest. Hey, actually, do I have the rest? I do not see the rest. Okay. Okay. So let me download this.
So for number 12, is the cumulative supposed to be in percentages or? Oh, I see it. Because that's the same thing I have.
If there are the cumulative frequencies, of course, that's not the percentage. It's numbers.
Okay.
Cumulative frequencies are numbers, right?
Right.
Okay. This says cumulative percentage. That's a word. There's a word. Yeah. That's why you see percentages. Okay. But if you want the cumulative frequencies, there's no that. Let me download this file. How to print this file?
Go up a little bit on the screen.
Here? No, that one.
The slide bar on your right. Keep going down a little bit, or over to your right a little bit. That arrow, hit that arrow.
Like that?
Yep.
Oh,
And
okay,
then-
okay, thank you. Okay. Now if that, then I can have.
Oh, the download button. Oh, well. That works too. You can hit the download button right there.
Okay. I think that this computer does not display the whole file. Well, that's what it looks like. Why this one is different from oh, I know what happened. Probably that one is not post. It's Excel. Excel. Do you see Excel? Excel. Oh, here. And then look at that. Right. Let's look at this. Yeah, this is the one I'm talking about. So I probably need to upload this. Let's get rid of this. I'll just upload that one. Then go to Excel. It's Now look at here. When you use Excel, it's this way. The first thing is you know where the data is, right? You need to know the location of the data. Also, you need to know where are the boundaries, right? Which we have done already, right? Data, we know where that is. Boundaries, we have determined already. So we know we have that and prepared. Now when you start from Excel, you make sure you find that data analysis. If you do not see data analysis, you go through this process to get data analysis. You click File, and then click Options, then Add Ins, then to pack, you come to this. Then check Analysis to pack. Okay, to get data analysis. From data analysis, you are able to see this histogram. Histogram. So you click a histogram. Then input range. That's where the data is located. Bin range. That's where boundaries are located. And then you're able to fit it. For the output range, actually you can display on the same sheet. Today I'm going to tell you that. I watched some videos and I found how to do that to show the result on the same page. So let's do this. Let's see. Okay. I'm going to delete everything. Okay. I'm going to delete everything. Okay. Delete everything. Okay. So let's start over.
So this is number 13, right?
That's number 13. You see that's number 13, right? Okay. The two biggest steps are here. One, you determine the interval. Two, you calculate the parentheses. Do you follow that? Okay. For short, I just read like this. Calculate or calculation and then parentheses. That's the second step. For the intervals, there are several steps. The first step is a range. The data is located from A2, A2 through A56. If you cannot remember, you type that here. Okay? A2 to A56. That's where data is located. Okay, so you do not need to look at that again. Step one is to find out the range. To find out the range, you calculate the max first. That is equal to max, then you use the data range. Data is from A2 to A56. Do you follow this? Okay, let me see if I can elapse it. I don't like that. No. Okay. Okay, to calculate the maximum, you use the function maximum. That's from A2 to A56, then you enter. Okay. The maximum is 7. Minimum. For minimum, that's the same, equal, minimum. Then the data range. Data range is from A2 to A56. All you do is selection. Okay, you did a selection. Now you close.
I might post a video on YouTube.
Then the range.
I might have to post a video on YouTube.
The range is a difference equal the maximum minus the minimum. That's a range. Second step is the number of intervals. Let's assume the number of intervals is 7. But for this question, I do not know what is the number of intervals. Can you check the book?
You said it was 13,
Number
right?
13, see how many intervals it asks.
says 7 classes.
7 classes, so 7 units. Okay, so 7, okay. So it is 7. 还有一种年代呢 right? Now third step is the width. Width. Width is, how you calculate width? It's a range, right? Divided by the number of intervals. Okay. If I enter this, you see it's that number. The data values are integers, so the width should be an integer. So we have to round this up to an integer. And with Excel, you can round this. You can use a round up function. R-O-U-N-D. If you do this function, you round that in the regular way. So you round that to 6. But if you round up, you add up. Okay. That's still a function. You see the function. Round up. Okay. Now you need to tell Excel. Round up to how many decimal places? We want the integer, right? Integer, that means there are no decimal places, right? So 0. You need to tell Excel that information, because if you did not tell Excel that information, Excel does not know what to do. Right? So now we tell Excel, please do the division, round it up to your integer. Then you get that. That's correct, right? You saw 6 point something, so we round it up to your integer. It's 7. Now we are able to determine the intervals. Okay. Let's see what's the minimum value. 41, right? Okay, I call that to group.
Can you make that bigger? I cannot see that.
Oh, that's right. I forgot. Thank you. I forgot to change it earlier because I'm doing something. Excel does not allow me to change. Now I can change.
Thank you.
Okay. Okay, I should do this earlier. Okay. I tried it earlier actually. When I was in the middle of some calculation, the Excel does not allow it. Okay, okay. And now first interval. First interval should be, the first boundary should be on the left side of 41, right? And we did this several times. So what's the lower boundary? What's the first boundary? It's on the left side, right? So it's 40.5. See that? Okay, that is correct. It's on the left side of 41. It has 1 decimal place. It's 40.5. So you answer those 2 conditions. Okay, on the left, 1 additional decimal place. Now what's the upper boundary? Equal. You did this from that question 3. If you have the lower boundary, you know the width, of course you know the upper boundary.
So why are you starting with 40 if the minimum is 27?
Where is minimum 27?
Right there.
Oh, sorry. I think I made a mistake. The minimum is 41, right?
27.
Oh, 27. Oh, you're right. So this is a mistake. Okay. Oh, okay, no. Don't. Something wrong. Okay. Let me back up. Let's look at the data.
Yeah,
Yeah, we did
27.
say 27, right?
Yeah.
So the mistake. So that is actually correct.
Yeah, but where you have 41 in green, that should be 27.
That's right. Okay. So I should not color this.
So now it's.
Okay, you're right.
Not 40.
I thought the number is ordered. Okay. We should highlight that now. Okay. So number is not ordered. Okay.
So that should be 26.5.
That's right. Okay, thank you. Okay. So you can find a problem. You can find the error. So you have no problem to solve the problem. Okay. Now we know the lower boundary. We know the width. So we are able to determine the upper boundary. So from the lower boundary, that's the left end of the interval, you add the width, you come to the upper boundary. So you type in the code, okay? Equal. Then click this, and then plus what?
7.
Plus width, right? I'm going to use the cell name. That's what?
E9.
E9. But my E9 does not change, right? It's a constant. So for that reason, I do $sign.
E $9.
E9.
No.
In this way, that number stays constant.
Okay.
When you drag it, it does not change. Okay, so $sign and that's part. Okay. Now what's this lower boundary? That's a second interval. Lower boundary is the same as the upper boundary of the preceding interval. So this is equal to that number, right? Okay. So you use that code. Okay, use that code. Now enter. Now what do you say? You say, I'm done. In fact, you are done. Okay, look. This side. You have a formula here, right? So you can drag this formula down. Do not see. Okay, let's look at the result.
I feel like you just made that.
Okay, you see. This number plus that 7. So that's correct. This is a feature of Excel. If you feel not familiar with this, you practice more times. Okay. So let's do this. Okay. Okay. So what do you want to do here? How would you calculate this? How would you calculate this? You do this. Oh, this plus 7, right? Well, with Excel, we do not have to type that again. When we drag this down, remember what's that 33.5? I mean behind that. What is the formula behind that? That basically said, the formula said, please add the number on the left. Let me see this. Please add the number on the left and the 7. Is that right? That's the code behind 33.5. Add the number on my left and 7, right? So if I drag that down, the code behind this cell is the same. Add my number on the left and 7. Add my number on the left and 7. That's what we need. Okay. So that's the feature. That's how Excel is designed. Okay, that's a matrix. Okay, that's a matrix. Now you can see this. If I drag this one down, what's this? What's the formula behind this number? Remember, behind this number it says, please equal to that number, right? So if I drag this down, please equal to that number, right? That's what we need. And you see it's true. So at this point, actually, you have everything. Okay. Okay. In fact, you can do this. You have all the numbers. Okay. 7 intervals. 7 intervals. Perfect. Okay. Okay, go back. The main thing is still here. Okay? Step 1, step 2, step 3, step 4. Okay? That's the part in the question where we determine the intervals. Okay. Other questions? No questions. Okay, good. Okay. Good? Is this good? Okay. Now let's move to the second part.
So when
This
we
part isn't
put
that
that into
bad.
our Word file, when we go to submit it, what's it gonna look like? Because obviously it's not just being Excel.
Okay, first, do not copy the data in your Word file. Okay?
Just the frequency table?
Do not copy the data. I think you probably can do like this. It's not done yet, but if it's done, you may copy like this.
Do I have what? Class after this? Today. Going back to Virginia today, but normally after this class.
Let's finish off this and then see.
I don't have any
It
other
all
plans
depends on
tonight,
the
so if you have
complete
any plans,
form. So when this is finished,
do you have
so
any
what
plans?
does it look like?
So you can call me or
Then you
FaceTime me.
copy,
Yeah.
right?
Okay.
However, you need to arrange this appropriately. Okay? Go ahead.
So you just want the frequency table?
Well, to that question, to that way, the answer is just the opposite. If the frequency table is provided, it's nothing. The thing is over here. The real thing is over here. So this part is more important. Okay, so this part, the first steps here, are more important. Okay. So this part needs to be provided. Okay. Frequency table is something as a consequence. Some people only show the frequencies. That's not enough. The process or the steps to determine the intervals is more important.
Okay, so you don't just want like a chart saying the limits, boundaries, frequency, and cumulative
Yes.
percentage. You want that
Yes.
as well.
Yes, everything. Okay.
Everything.
But let's finish up with the boundaries. Okay.
So this is the way mine looks. Right there.
Okay. Let's do this way. Okay. Let's do this way. Okay. It's like this. You write. Okay. Everybody, you look at this. Okay. First step.
That's how it's. Yeah, the limits, boundaries, frequency, and the
Okay.
cumulative percentage.
Step
But
1.
it's this one.
Through step
So
4.
that's the histogram,
Okay.
and then this
So you have the
one.
interval.
And then this is all
And then you
the
have the
other stuff.
frequency table.
So that's the one
This is
Your actual
yeah,
question
this
is
box or
what
talking
columns
about?
should be equal?
this box. So the
Or you have the
limits
boundaries.
is right the lower. It's just like the regular stuff at the help.
Which one are you gonna submit?
This one.
This one?
I've got
You have
add in
limits.
like this stuff and like how I got that answer, but other than that, like that's it. Because I can write with this thing, so I like draw
You have
arrows
limits.
and like how I got it and stuff.
And then you have
So,
frequency. You have relative frequency. You have cumulative frequency.
is this still number 13?
Yes, every
This is okay.
cumulative
Oh, it's showing
Relative.
how he wants it done.
Oh, okay,
frequency.
like you did,
That's a complete table. Do you see this?
So limits.
I think the question is answered by this, right? So this is what you want to show. Okay. The first step, and then the result.
So okay.
The first step,
First step to determine the intervals.
so all of that.
And then beyond that, you use Excel to calculate. But at the end, you need to organize into this form. So we're doing this. Okay, we're still doing this. Okay. We're in the middle of this. Okay. So far we have done the first four steps, right? Is that right?
Right.
Okay. So let's see the next. Okay. Now we have the intervals, right? Okay. We are going to use a histogram to calculate the frequencies. Let's remember the data. We know the data. Let's also remember the boundaries. The boundaries will be from 33.5 to 68.5. Am I right? I explained already earlier. Do not use the very first boundary. Do not use the very last boundary, because when you use the second boundary, 33.5, Excel by the design, by default, it calculates the number, it counts the numbers on the left. So that's the number of values between 26.5 and 33.5. So you do not need the very first. By a simple reason, you do not need the last one. So the boundaries are located. What's this? Can I quit this? Well, let's do not do that. Okay. Excel may feel bad. Let's take a risk. No, remove the files. I have saved them. I do not know if I have saved. So let's just don't worry about it. Let me see. Okay, now, close. I have saved. Release. Okay. It's a big risk. I just wonder if we'll delete this. Delete everything. Okay. Now, the boundaries are located from F12 to F17. F12 to F17. Okay. Excel is not case sensitive. Okay, so you can use a lowercase letters. Okay, that's boundary. Okay, data is here. Boundaries are here. Now you are able to use a histogram. Data analysis. You choose histogram. You say OK. This time, this is shared, right? So those on website can see this, right? Yeah. Okay, good. Now for the data, you type A2. Remember the dollar sign, okay? 2 dollar sign A36. Or you can do by selection. The boundaries, that's F 12 to F 17. Any question about this? No question. Do you have any question here? Okay. You can actually do this. Control Alter print script. Okay. Then you go to here, and then you do a paste. And so it's like this. Well, that's great. I can put them together into that file. I cannot do that, but I know it's in my mouse. Okay. I have that in my mouse. Okay. So let me finish up this. Okay. Now, for the output range, today I tell you a little bit more, okay? Click it. What is the output range? Well, you cannot see here, right? You cannot see here, but you can see here, because you don't have anything to the right below that. So you can see here. Can you? Yes. If you do like this, Excel put the result over here. Now let's see what we need. Labels. It's not per the chart. Cumulative percentages. Frequencies will be displayed automatically. And then chart of. Let's try this and see if it works. Okay. I guess I have to do this again. So it's good. Okay. I need to go back. Before I click. What I do? Go back. Go back. And then paste. So this has more options. So then you do selection. I'm trying to put this in the Excel file. Let's see. That's right. Now, okay. You see, everything is placed here. Wonderful. I learned this morning. Okay? I told people in another class, I said, okay, you need to watch this video, but I do not know if it's good or not. Okay. We thought they talked about this, but they discussed something else. But how we found this. Now I see the frequencies, right? Is that right? Why it's just a 6 number? How many numbers we should have? We should have 7. We should have 7 numbers. Why we won't have 6 here?
Because you only use 6 of the boundaries.
No. When you use 6, you should have 7 numbers. Left or right. You should have 7. Well, probably they said more.
So what should that more be? Should that be the 78.5 or whatever the other one is?
Okay, so I don't know what happened here. Or something is wrong. Usually it's not this. So I think let's check that. That's 12 to 17. So we did correct. But something is wrong with the Excel. We may go back to check. Cannot go back to that because you go back to this. You cannot go back. numbers. Remember, if we use 6 numbers, we should have 7 frequencies, because Excel counts the number values below, also the number of values above. So we should have 7. Where it shows us only 6. Let's do this again. Data analysis. Click OK. A2 to A36, that's correct. F12. F12, that's 33.5. F17, that's this one. So we use 6 numbers. Output range. Let me delete this and see what happens. I think output range could cause a problem. Cannot remove that. Can I remove that? Let me remove it. Oh, you have to do that. Do not use that. That's it. New workspace. Okay, that's new. Now let's do this again. How many numbers we have now? 7, right? Do you see that? That's 7. So something is wrong from the Excel. Oh, the place I placed it there has some problem, so that one number is covered. But that's not the case, because this new sheet is shows 7 numbers. So I'll leave this as a pattern for you to check, okay? Once you found that a bug, if it's a bug in Excel, then you write to Excel. You will. Okay, so that's good. So let's make that correction. Delete this. Delete it. Okay, delete it. Okay. Now let's do this again. Data analysis. It's physical. Okay. Now I copy this. I want to make this correct. Okay. Remember, I still need to be changed over here. I want to make sure it's correct. I don't want to have a mistake.
So this here is everything that you want us to show on the
Yes.
thing we submit.
You're going to see it. Later we'll discuss it. No. Okay. Now, where we are? Next week, right? Let me copy the process here. That space, I think, why the space? When you perform something, then information in the notes is covered. Too big. You can reduce yourself. So that's what the table looks like. I don't have space. I have to. When you read it, you can make that up. Now these are the intervals. You don't need this. You really don't need it. And now the boundaries. Limits. Lower limit, upper limit, and middle. And then frequency. That's the X. Cumulative. Small. Relative. Cumulative. Relative. So the table will be like this. But for those, the calculation is very easy. For example, for limits, you can write that out. That's for 27 to, well, actually, you can do this. Lower limit, number minus 0.5 equal this lower limit, plus 0.5. Here follow this. Agree? Plus 0.5 for the lower limit. For upper limit, you reduce 0.5 from this, right? Middle point, that's the average. Of this number. Parentheses, you have that category just copy, right? Am I right?
You're copying that from the chart that you make
Yes.
from, okay.
Yes, that is from this, I think it's from shape. Our shape is 1. Cumulative function, this is this one, the second. Second is this plus this. And then you drag, okay, all the way. Okay, you can hold this number plus that. Relative function, you change this to proportion. So this number divides the total. And what is the total? 56 minus 1 is 55. Right? Or data is from A2 to this 56. So minus 1. 56 minus 1, 55. Relative function. You can change that to the decimal places easily. Cumulative function, the calculation is like this. Count this. You probably, some people do not know what I'm doing. Okay, the formula is the same as this. Okay. Okay, now to your question, what needs to be on the in the file? I mean the word file. Well, you need to look at the hand here, the entire situation. If you look at the entire situation, then you will make this smaller. You see what it is. That's everything we have, right? So I think this will be good. This will be good. Right? Is that good? So for your question, it's just like this. You copy this part into the word. But make sure in the word file it is readable, okay? The size, the font needs to be correct, okay, to make sure it's readable. So when you copy this to the word file, let's see. You see word? Where do you want? Let's share the word. I think it's shared, but I'm not sure.
It's shared.
Oh, it's shared. Now you paste it. When you paste it here, just look at it. You need to adjust so that it's not close. Where is the end? You see, you do not see the end. Okay. So you cannot give something like this to me. Okay. You must adjust the set so that you can see everything. So how to do this? Okay, so that's why we can do. Okay, so now you see the end. When you see the end, you can reduce the set. And then you can move it back. Well, you can move it back. So that is done. Right? That is too small. Okay, that's how you do the work. Okay, I think this is good enough. Okay. Work is equal. Okay. Time reason, we cannot do any more questions. Okay. But for number 7, remember there are 2 data sets. You need to combine the data sets together first to produce one set of universe. do not work on a data set separately, so you have two sets of intervals, which will not match. So combine the data to produce just one set of intervals. And then you display each data separately. Okay? And for that one, it ought to be arranged together, do not need a lot, just 1998 frequencies, cumulative frequencies, that's enough. Okay? Do not have to have everything like a relative frequency, cumulative relative. Right? That's simplified by reducing this. So that for two columns, you can display for one data set, and the next two columns you display for the other data set. So the comparison appears in that table. So that is, takes the whole page. Okay, so much for this. So same. How about this file? Is this file in the file save? So this is new file. It's updated, right? It's updated. So we need to go to the canvas. Update this. Now it's not there. It's in the homework. Number 13. That's 1.134. So it's new. So now it's update. Let me correct the errors before we move forward. For another class, I think I made a mistake. Okay. Now our point to finish up the rest. The very last part is about the so-called other types of graphs. Look at this. This is so-called a Pareto chart. This chart is used for category data. Look at here. Here, it's the data is about the ways people come to work. So some people come to work by driving, you see, auto. Some people come to work by taking a bus. Some people come to work by walking there if they are close. Okay. Suppose we have a data set, survey data from this. How to create a figure to display the data is this bar graph. For this bar graph, each category takes a horizontal space. The height of the rectangle tells us the frequency. But the categories must be arranged into this particular order so that the frequencies become smaller and smaller from left to the right side. When a graph is like this, it's called Pareto chart. If you change the order, it's still called a graph, still a histogram, but no longer called Pareto chart. So if the question asks Pareto chart, and you switch the order, your answer is wrong. Okay? Second, time series. Time series graph is often used previously. Pareto chart is used to study category, right? Another possible example is like blood types. Still another one is like the colors of helmets of motorcycle drivers. So if we study the safety regarding the helmets colors, or related to the colors of helmets, in that case, we use a graph like this. All kinds of blood. Time series. Time series by the name is about the data that is related to time. For example, growth chart of a child. Growth chart. That is based on time. So At this time, what is the height? At another time, what is the height? At this time, what is the weight? At another time, what is the weight? At this time, what's the, how you measure that? So, do you know the term for that? They measure an infant, like a height or length, weight, and also the yes, that's circumference. Okay, they measure that. That is also important. If that is too big or that is too small, it's a problem. Right? Too big may not be a problem, but too small, I think, would be a problem. We do not know what they measure it. That's time series, right? Because the infant is growing over the time, right? So anything regarding time can be studied like this, like a market, stock market, right? The market changes over time, right? So you can study like this. And also you can do comparison between two time series. In fact, there is something that is related to calculus. It's called co-integration. That study was done by economics who received Nobel. Time window continuous graph. Time graph, okay? So you can use this to study category. Last one is stem and leaf plot display, or stem and leaf plot. So let me explain this. Here we have a data set. The data set has a name. It's about the outpatient test center. You know that, right? Outside the hospital, there's a test center, right? Oh, maybe, I'm sorry. It's inside the hospital for outside patients. Is that right?
Yes.
Okay. So each day, they can perform a certain number of tests. This is a record for 20 days. For the first of the 20 days, they perform 25 tests. For a second of the 20 days, they performed 31. For the last of the 20 days, they performed 45, right? So that's what they have. Now let's see what data information we can have if we apply the so-called stem and leaf distribution. You want what is the stem and leaf distribution? And look at here. I make that big, okay? What's a stem and leaf distribution? Look at those data values. They are quite similar. Each one has 2 digits, except one value that's 2. But for that, you can make a 0 in front.